I want to talk about interval notation, and I also want to talk about absolute value inequalities and certain types of absolute value inequalities. Okay, so interval notation. Let's just write that word down just so we can see it. Interval notation. Notation. Now, what we're talking about with interval notation is an interval of numbers. That is a set of numbers, and it's an interval meaning all the little tiny numbers in between those two numbers as well. So if you imagine all the numbers between 1 and 2, well, there's 1.5, there's 1.25, there's 1.01, 1.001, 1.00000. There's an infinite amount of numbers between 1 and 2. So whenever we use an interval, we are talking about all of the tiny real numbers that are between any two real numbers. So whenever we use interval notation, we have several rules. One of those rules is that when we use a bracket, we can use brackets, and this tells us that it's included. Or we could use parentheses, and parentheses tells us that it's not included. Okay, well, what do you really mean by that? Well, let's take a look at a number line for a second. If I want to describe all of the numbers on a number line, let's say I want to talk about all the numbers on a number line between, well, let's just pick a random number. Let's say -4 and 8. So I want to say all of the real numbers between -4 and 8. Well, let's say I don't want to include -4. So I have an open circle at -4, but I do want to include 8. So 8 can work. 8 is definitely a part of this interval, but -4 is not. So I'm going to say, I'm going to shade all of this in between. Here we go, little curly cues. All right. So all of the numbers between -4 and 8, not including -4, but I am including 8. And I would show that on interval notation by saying not including -4 and going all the way until I get to 8. And I include 8. So I have all the numbers between -4 and 8, not including -4, but I am including 8. And that's what it looks like on a number line, and this is what it looks like with interval notation. Oh, okay. So what happens then if I have a set of numbers on a number line? Let's say here I have a number line, and let's say I want to talk about all of the numbers that are, well, here's 0. So I want to talk about all the numbers that are less than -2, and let's include that. So we have -2, everything that is less than -2, and I'm going to keep going all the way to -infinity. And I also want to talk about all the numbers that are bigger than, oh, let's use 4, because I like 4 is one of my favorite numbers. And we're including 4 here, so we'll talk about all of those numbers as well. So how can we describe these? Well, clearly I have two different sets of numbers or two different intervals of numbers. I've got this one here, and I have this interval over here. So I want to talk about this interval first. And reading left to right, we're going from the smallest to largest. The smallest number I see here is going to be -infinity. It goes all the way from -infinity. Let's get a good infinity there. -infinity. Now, I'll never actually get to -infinity, so -infinity is not included. And I'm going to go all the way to -2, but -2 is included. And then I have this set of numbers over here. Well, this is 1, 2, 3. This is at 4. So starting at 4, I'm going to include 4. And I'm going to go all the way until I get to infinity. Infinity. And again, I can't include infinity, so I always have a parentheses around infinity. That's one of our rules here when we use interval notation. Now, one way of thinking about this is, let's say that x can take on all of the values in this region or this region, right? X can be anything less than -2, or, let me use the word or here, or x can be bigger than 4. And mathematically, we use a symbol that's called the union. So here's a union. And notice it looks like a capital U, but there's no tail. It's just a union symbol, has no tail on the U there. Okay, so now this mathematically tells me that I'm looking at all the numbers between -infinity and -2, including -2, or all the numbers between 4 and infinity, including 4. Now, we've already talked about set builder notation, so let's describe this using set builder notation. In set builder notation, I would describe this as the set of all x values such that x is less than or equal to -2, or x is greater than or equal to 4. And I'm going to close my set. Now here, again, using interval notation, and here this is using set builder notation. Now I'm introducing this notation and this way of thinking about it because we're going to start dealing with problems like the absolute value of x is less than 6. Well, man, that's going to be tough to talk about. The absolute value, again, the distance away from 0, so my distance away from 0 on a number line is less than 6. Just to describe the idea of the distance away from 0 on a number line being smaller than 6. Well, here's 0, and let's go 1, 2, 3, 4, 5, 6. Here's -6, and I have 1, 2, 3, 4, 5, 6. Here's +6. Distance away from 0 is less than 6. Okay, so what about, let's say, what about -9? Is -9 less than 6 units away from 0? Well, no. So I know here at 6, I'm going to put an open circle. And I can go from 0 all the way to 6, but I don't want to include it because it's not included. This is a strictly less than. It's not less than or equal to, it's strictly less than. So I'm put an open circle at 6 as well. And now I'm going to include all of these numbers here. So between -6 and 6, my distance away from 0 is definitely going to be less than 6. And we could describe this scenario using an interval notation by saying, well, here at -6, I have a parenthesis, so it goes from -6, and I'm including all of these numbers, and I get to 6. And again, this is going to be a parenthesis because I'm not including 6. It's an open circle. I'm strictly less than. Okay? And using set builder notation, I can say that this is the set of all x values such that I'm between -6 and 6. And that's a strictly less than sign there. The set of all x values such that I read this as x is between -6 and 6, not including -6 or 6. So -6 is less than or equal to, less than x and less than 6. Okay. Not too bad. Now what happens then if we have something like the absolute value of x minus 3, and let's say that that is less than or equal to 4. Okay, so just like we did a minute ago, we were looking at how that distance away from 0 was less than 6. Well, here I'm looking at an algebraic inequality here, where I now have x minus 3, that absolute value has to be less than or equal to 4. Okay, so let's look at this on a number line for a second. Let's just take a look on a number line. We could see here that, there's my pen. I have my numbers going all the way that way and that way. Here I am at 0, -1, -2, -3, -4. So I need all of these distances, and then I have 1, 2, 3, and 4. So this distance away from 0 on a number line, it goes from -4 all the way to 4. All of these numbers would be included for x minus 3. In other words, x minus 3 has to be between -4 and 4. I would say that x minus 3 has to be between -4 and 4, and that's less than or equal to, so I need to say that less than or equal to. Now look at this compound inequality that we've created. This compound inequality that we created says -4 is less than or equal to x minus 3, which is less than or equal to 4. And just like we would just like we would solve for an equal sign or solve with any other inequality or just a single inequality, with compound inequalities, what you do to one section, you have to do to all three. So in order to get x by itself, I have to add 3. And I'm going to add 3 to everybody. And now, negative 4 plus 3 is negative 1, which is less than or equal to x, which is less than or equal to 4 plus 3 gives me 7. Okay. Well, I could show that solution set on a number line, no problem. Here's our number line. And if you haven't caught on yet, number lines are extremely important for you to help see. Get a little visual as to what's going on. Here we are at 7. Okay, so between negative 1 and 7, and then I'm including negative 1, and I'm including 7. And I want to shade all of the numbers between negative 1 and 7. And this would be the value that x can have in the original problem. Well, okay, so now let's take a look. Let's take a look at how this answer would be using interval notation. Well, using interval notation, we're talking about all the numbers between negative 1 and 7, starting with negative 1, and we go all the way to 7. Now, I want to include negative 1. Notice there's a closed circle. Notice that it's less than or equal to, so I want to include negative 1, and I want to include 7. And that, using interval notation, tells me the answer to the problem. In set builder notation, we would say the set of x values such that x is between, that's negative 1, less than or equal to x, which is less than or equal to 7. So the solution, the answer that we found, the final answer that we found simply goes right here in the set builder notation. Nothing different from the answer I found to set builder notation. I just got fancy and I said the set of x values such that negative 1 is less than or equal to x, which is less than or equal to 7. And then I close my set because I'm done with it.